गेट 2021 का काउंटडाउन शुरू हो चुका है एंड नाउ वी आर इन द एंड गेम।
इतने सारे चैप्टर्स, इतने सारे सब्जेक्ट्स, क्वेश्चंस लगाएं या थ्योरी पढ़ें, लॉट ऑफ थिंग्स आर गोइंग इनटू माइंड।
आप सोचते क्या पढ़े क्या छोड़े, कहां से पढ़े किससे पढ़े। Unacademy brings you a new crash course where you get complete syllabus with best solutions.
आपको मिलेगा हर क्वेश्चन का जवाब हमारे नए क्रैश कोर्स उम्मीद में।
एक कंप्लीट सीरीज विद फुल सिलेबस, होंगे 10 बेस्ट एजुकेटर जो मिलके बनाएंगे आपकी जिंदगी को आसान।
35 दिनों में कंप्लीट सिलेबस विद बेस्ट क्वेश्चंस।
सारे सब्जेक्ट्स बस एक चैनल पे, तो देर किस बात की, हो जाओ तैयार गेट 2021 को क्रैक करने के लिए।
तो मिलते हैं 20 दिसंबर को, लिंक इन डिस्क्रिप्शन।
लेट्स क्रैक इट। सबसे पहला क्वेश्चन या
एक ओवरऑल अपने पास सिनेरियो ये बन गया।
इलेक्ट्रिक फील्ड का फंक्शन क्या होगा?
Then it will be off.
गेट 2021 का काउंटडाउन शुरू हो चुका है एंड नाउ वी आर इन द एंड गेम।
इतने सारे चैप्टर्स, इतने सारे सब्जेक्ट्स, क्वेश्चंस लगाएं या थ्योरी पढ़ें, लॉट ऑफ थिंग्स आर गोइंग इनटू माइंड।
आप सोचते क्या पढ़े क्या छोड़े, कहां से पढ़े किससे पढ़े। Unacademy brings you a new crash course where you get complete syllabus with best solutions.
आपको मिलेगा हर क्वेश्चन का जवाब हमारे नए क्रैश कोर्स उम्मीद में।
एक कंप्लीट सीरीज विद फुल सिलेबस, होंगे 10 बेस्ट एजुकेटर जो मिलके बनाएंगे आपकी जिंदगी को आसान।
35 दिनों में कंप्लीट सिलेबस विद बेस्ट क्वेश्चंस।
सारे सब्जेक्ट्स बस एक चैनल पे, तो देर किस बात की, हो जाओ तैयार गेट 2021 को क्रैक करने के लिए।
तो मिलते हैं 20 दिसंबर को, लिंक इन डिस्क्रिप्शन।
लेट्स क्रैक इट। सबसे पहला क्वेश्चन या
एक ओवरऑल अपने पास सिनेरियो ये बन गया।
इलेक्ट्रिक फील्ड का फंक्शन क्या होगा?
Then it will be off.
गेट 2021 का काउंटडाउन शुरू हो चुका है एंड नाउ वी आर इन द एंड गेम।
इतने सारे चैप्टर्स, इतने सारे सब्जेक्ट्स, क्वेश्चंस लगाएं या थ्योरी पढ़ें, लॉट ऑफ थिंग्स आर गोइंग इनटू माइंड।
आप सोचते क्या पढ़े क्या छोड़े, कहां से पढ़े किससे पढ़े। Unacademy brings you a new crash course where you get complete syllabus with best solutions.
आपको मिलेगा हर क्वेश्चन का जवाब हमारे नए क्रैश कोर्स उम्मीद में।
एक कंप्लीट सीरीज विद फुल सिलेबस, होंगे 10 बेस्ट एजुकेटर जो मिलके बनाएंगे आपकी जिंदगी को आसान।
35 दिनों में कंप्लीट सिलेबस विद बेस्ट क्वेश्चंस।
सारे सब्जेक्ट्स बस एक चैनल पे, तो देर किस बात की, हो जाओ तैयार गेट 2021 को क्रैक करने के लिए।
तो मिलते हैं 20 दिसंबर को, लिंक इन डिस्क्रिप्शन।
लेट्स क्रैक इट। सबसे पहला क्वेश्चन या
एक ओवरऑल अपने पास सिनेरियो।
गुड इवनिंग एवरीबॉडी। प्लीज ऑब्जर्व कि आपको जो है अपीयरेंस आ रहा है और वॉइस आ रही है। एक बार ज़रा देख के मुझे बताइएगा। इफ़ यू आर एबल टू हेयर मी एंड यू आर एबल टू सी मी, प्लीज़ राइट इन द कमेंट सेक्शन, देन आई एम गोइंग टू प्रोसीड फर्दर। ओके, सो टुडेज क्लास इज फॉर द स्पीड कंट्रोल ऑफ torque speed characteristic curve and some numericals, okay, based on the torque speed characteristic curve. Okay, so by yesterday we have completed the torque speed characteristic curve by using a Thevenin power flow model. Okay, so today I am going to discuss some numericals based on that also, and I am also going to discuss about the small portion of the speed control. Okay, please let me know if you are able to hear me. Hoping ki everything is okay. Okay, so on my screen everything is okay. See, I am Varun Srivastav. So I am hoping all of you are aware with this. I am expert in GATE and ESE and mentored more than 70,000 students on both online and offline platform. So many of them achieve a very good rank, and maybe you are also going to be a future of my student who is going to achieve a very good rank. You can use my code for subscription or for login on Unacademy app. Okay, so Unacademy mobile application needs a code after installation. You can use my code, that is VST101, and if you willing to purchase any subscription, you can use my code in order to get 10% discount. My area of subjects are my subjects are electrical machine, control systems and digital electronics. Now see, I am running one series named Synchronous Numerical series on Unacademy app, and for that only you have to download the app, and then you can enjoy the free lectures. Okay, so this is a special free classes on Unacademy mobile app. Okay, so you can just download and you can enjoy these lectures. सर कोर्स फी क्या रहेगा? अच्छा, सिर्फ मशीन लेने का. सो अभी तक मैंने लॉन्च नहीं किया है ऐसा कोई प्लस का कोर्स. Soon whenever I am going to launch, I will intimate you on some lectures. Okay, so you have to follow me on Unacademy as unacademy.com@machine.varun. So if you are going to follow me, you will get all the information. Okay, so जितने भी आपके कोर्सेज आएंगे वो आप पा जाएंगे. ठीक है, प्लस कोर्सेज में स्टार्ट करूंगा, बट अभी थोड़ा सा और फोकस कर लेते हैं, फिर करेंगे. ठीक है, नाउ प्लीज ऑब्जर्व हियर. फॉर डाउनलोडिंग ऐप you have to follow a very simple steps. The first step is you have to just search on a Google Play Store for Unacademy app. It is very popular, so just whenever you are just writing the name, you will get the link. Okay, and then you have to download and open it. Okay, now please see here. Two types of paid courses are available. After downloading, you will get this. After downloading, you will get the two types of courses available. You can purchase any one of them. One is your plus and one is your iconic. If you go with the plus one, then with the plus one you are going to get live classes. Okay, where you can talk to the educator also. Crash courses, weekly test, doubt solving sessions in both the languages English and Hindi, and also there will be a batch named rank improvement batch. So this is going to help you a lot. Okay, for plus the fee structure will be 27,225 for 12-month plan, and for 18-month plan it is 34,650, and for 24-month plan it is 39,600. So depending upon your convenience, you can choose any one of them. The plus will have features. Along with the plus feature, one more course, that is iconic, and iconic will have more features than plus. If you observe here, the plus will have a circle. So all including plus, iconic also carries personal coach. This is an extra feature. So you are going to get a personal coach who is going to assist you how to study, okay, and how to make a timetable for you are going to watch on the paid courses. Then study planning, that is the part of that. Then study booster sessions you are getting, that is extra part. And the most favorite, this is my favorite one. So this is your personalized test analysis. Okay, so that makes improvement in your upcoming examinations. Okay, so once you know about your common mistakes, you will able to handle them. Now one more thing, that is your printed specialized study materials. Okay, so this iconic will have an extra feature along with this plus feature, and definitely the fee structure will be different. So the fee structure is, if you observe, for 12-month plan, that is 45,225, you can use my code in order to get 10% additional discount. For 24 month it is 66,600, but this fee structure is a very small. Why, sir? Because it carries both GATE and ESE and along with a lot of features. Okay, so if you compare it with some offline classes, this fee structure will be very economical. Okay, so if you are willing to join, you can join the iconic one that I suggest you. Now please observe, two different batches are already running. You can join any one of them. If you are from the electronics or instrumentation branch, then you can join this batch, Evolve for GATE 2022. This batch is in both the languages, English and Hindi, and the major educators are Vishal Soni sir, Suresh VSR sir, and Siddharth sir, BV Reddy sir. So these are the major educators. Along with this, there are some more educators available in this particular batch. So you are going to enjoy this particular batch. Okay, so I recommend, if you want, you have to go with this batch. This batch is already running from the 21st of December. However, you will get the subscription yet. Now please observe, another batch is GATE 2022. So if you observe GATE 2022 Evolve batch for electrical student, this batch is also started from 21st of December, and the major educators are Ankit Goyal sir, Ajay Gupta sir, Kaser Hafiz sir, BV Reddy sir, and Suresh VSR sir. In order to purchase this, you can use my code BST101. You will get additional 10% discount. Now please observe, I am hoping up to this everything is clear to you. Please let me know once, just by writing on the comment section. Haji. Okay, now see. Now please see. Today I am going to discuss about the torque speed characteristic curve and some numericals. So I am going to take from the yesterday class, that is torque speed characteristic curve. So till now we have completed. I am going to take a quick recall and then we proceed further. If everything is okay, just make a thumb. Just make a thumb. If everything is okay and you are getting all the information, then just make a thumb so that I can proceed for today's class. You need to share this lecture also on your social media platforms like Facebook, Instagram, Telegram, or whatever you have. So you have many other WhatsApp groups also. So if you are going to share, more number of students are going to be benefited by this free crash course. Okay, everything is okay, sir. Now please see, till now I have completed torque speed characteristic curve. So I am writing here as a torque speed curve. Torque speed curve of three-phase induction machine. So now please see torque speed curve. Sir, we have completed up to this part, that torque speed curve can be represented in this way. Please see, this will be your speed and this side is your slip. Okay, so I am just taking a quick recall. Please see. Sir, at S is equals to, at slip S is equals to 0, torque is 0. And at slip S is equals to 1, when NR is equals to NS, we found the torque to be in a low slip zone as proportional to slip, and torque in a high slip zone as inversely proportional to slip. Is it okay? I have also told you about the slip at which torque is maximum, slip at which torque is maximum, and for a maximum torque also. Yes sir, till now we have completed up to this part. Torque in a low slip zone, torque in a high slip zone. So this is what we call high slip zone and low slip zone. Okay, starting is your TST. Yes sir. Now please see here. We have all the relations of the torque under different slip condition when stator impedances are neglected. So I am taking from the expression models. Okay, so just see about the expressions. Just see about the expressions, sir. Torque in a low slip zone, we have low slip zone torque expression we obtained as torque is equals to 3 by, this is just a quick recall, please observe, V1 is square by R2 dash into S. Yes sir, this is the torque in a low slip zone. If we talk about high slip zone, then torque in a high slip zone is torque is equals to 3 upon omega Sm into V1 square by x2 dash square into R2 dash by S. Yes sir. Okay, so this is your torque in a high slip zone. We have two more relations. This is very important for numerical. So please, you can note it. Then maximum torque expression is maximum torque. If you talk about maximum torque, then maximum torque expression in case if stator impedances are neglected. All these relations are when stator impedances are neglected. When stator impedances are neglected. So all these expressions are for the on neglecting stator impedances. Okay. Maximum torque is your 3 by omega Sm into, sir, this will become, Haji beta, V1 square by x2 dash. I am hoping up to this part you are comfortable. All these expressions are already I have derived yesterday. Everything is okay. Now see. So we have a torque expressions under different slip condition, and also we have slip at which torque is maximum. So slip at which torque is maximum is defined as R2 dash by x2 dash. R2 dash by x2 dash. Yes sir. Let me make it as x2 dash. Is it okay? Yes sir. So from here we have observed, in case if we are going to change the rotor resistance, then the torque under constant slip condition changes. The max torque in a low slip zone changes inversely proportional to rotor resistance. Torque in a high slip zone changes directly proportional to rotor resistance at same slip, and maximum torque is not affected by the change in rotor resistance. Slip at which torque is maximum is going to be change, or it you can say increases with the increase in rotor resistance. So how we can increase the rotor resistance? By using a slip ring induction machine and facilitating the process of insertion of external resistance. Okay. Now please observe. Now please observe. Up to this part already I have completed yesterday. Now please observe. From the torque slip characteristic curve here available, you can say, sir, now we can find the relation between starting torque to maximum torque. I am interested to find the relation between starting torque and maximum torque. So, relation between starting torque and maximum torque. Now please see, most of the questions asked in GATE from this particular topic. Please see, you can say, sir, starting torque, if we observe torque in a induction motor is 3 by omega Sm into V1 square by R2 dash by S square plus of X2 dash square into R2 dash by S. Yes, sir. Sir, this is the expression when we neglect the stator impedances, okay, and without approximation. We found this by approximating, that is in a low slip zone, in a high slip zone. But if we talk about the torque expression, then torque expression is this in general on neglecting stator impedances. So I am also mentioning here on neglecting stator impedances. I am mentioning here on neglecting stator impedances. Please observe, this is very important. Once you are able to understand, the numericals will become very easy for you. Sir, when we talk about the starting torque, then at the time of start, NR is equals to 0. Yes. So for NR is equals to 0, slip S is equals to 1. For slip S is equals to 1, you can say, sir, 3 by omega Sm into V1 square by, please observe, R2 dash square plus of X2 dash square into R2 dash by S. Okay? Yes, sir. Now please see, slip S is equals to 1, sir. Slip S is equals to 1 because I am talking about the starting condition. So at the time of start, slip S is equals to 1. Okay? Now come to the maximum torque. Maximum torque will become, sir, 3 by 2 omega Sm. Let me correct it here also. Okay, let me correct it here also. Please correct it. See, 3 by 2 omega Sm, 3 by 2 omega Sm into V1 square by X2 dash square. Please see. Yes, sir. So now we have a starting torque and a torque on neglecting the stator impedances. If we have to find the relation, just divide, or you can find the ratio of these two. So if I am going to find the ratio, I am just going to divide it by starting torque divided by maximum torque. So when I am going to do this starting torque to maximum torque, then you can say, sir, this will become, please observe, 3 by omega will cancel out, 2x2 dash will come into the numerator along with this r2 dash. V1 square will cancel out, so you will get 2 r2 dash x2 dash upon root over of, upon R2 dash square, I am representing this, plus of X2 dash square. Okay? Yes, sir. So let me make in this way. So it looks like a ratio. Is it okay? Yes, sir. Please observe. You can say, sir, you may write this expression as, by again, you can write it as TST by T max is equals to 2. You can write this one as 1 by R2 dash X2 dash and R2 dash and R2 dash square. So R2 dash square will cancel out dash by X2 dash. So in the denominator you are getting R2 dash by X2 dash. Okay? Plus of, please see here, 1 by R2 dash and X2 dash. By multiplying here, you will get X2 dash square, X2 dash will cancel out. So you will get R2 dash, R2 dash. Yes, sir. So this will become X2 dash by R2 dash. understand this? Now please do that, sir, since slip at which torque is maximum is equals to R2 dash by X2 dash in case if the stator impedances are neglected. Therefore, starting torque to maximum torque can be represented as 2 upon this R2 dash by X2 dash will become slip at which torque is maximum. So let me represent it in this way. Slip at which torque is maximum. This expression is very helpful for finding the relation between starting torque. So, or the slip at which torque is maximum. Please let me know if you are able to understand this. Haji, mic problem? The mic disturb हो रहा है. ऐसा कैसे हो रहा है? Let me check. Now see अभी डिस्टरबेंस खत्म हो गया क्या? मुझे बताइएगा बेटा अभी क्या डिस्टरबेंस खत्म हो गया? बहुत ज्यादा हो रहा है सर. Please check. Now everything is okay. Please check. अरे यार ये क्या हो रहा है? Everything is okay now? Okay. So sir, we have slip at which torque is maximum to maximum torque as 2 upon St max by 1 plus 1 by St max. Let us solve one numerical based on this, okay? See. Please see, I am writing it very fast. So, three-phase squirrel cage induction motor, a three-phase squirrel cage induction motor, a three-phase squirrel cage induction motor has a torque, has a starting torque of has a starting torque of 150% of full load torque. So I'm just writing 1.5 times of full load torque, and maximum torque is 3 times of full load torque. 3 times of full load torque at rated voltage and rated frequency. 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 Rated voltage and rated frequency. rated voltage and rated frequency. Neglect stator resistance and rotational losses. Neglect stator resistance and rotational losses. Neglect stator resistance and rotational losses. आज बड़ा जबरदस्त क्लास है, थोड़ा न्यूमेरिकल्स पे ध्यान देंगे. ओके सर. On neglecting the stator resistance and rotational losses, the value of slip at which torque is maximum. The value of slip at which torque is maximum The value of slip at which torque is maximum. So please try to solve this. It is very easy to solve. Please try to solve this. I have to tell you one more thing. The value of slip at which torque is maximum. I am writing it in terms of value as 0.1348, 0.1892, 0.2679 or 0.1642. Now you have to find the slip at which torque is maximum. You have to find the slip at which torque is maximum. सर आपके मूव करने से माइक भी घूम रहा है तो बीच बीच में डिस्टरबेंस हो रहा है. ऐसा होना तो नहीं चाहिए यार, ये तो नया माइक है. पता नहीं क्या इसे कर सकता है. चलो मैं हाथ में लेके पढ़ाऊंगा. See, now try to solve this. Sir, please see. Everything is okay? Now please see. Sir, we have a relation for maximum torque and starting torque as starting torque to maximum torque ratio on neglecting stator impedances is equals to 2 upon slip at which torque is maximum by 1 plus 1 by slip at which torque is maximum. Yes sir. Now we have a starting torque to be equals to 1.5 times of the full load torque and maximum torque is equals to 3 times of the full load torque. So sir, we can write it as starting torque as 1.5 by 3. Full load torque will cancel out, so this will be equals to twice of slip at which torque is maximum upon slip at which torque is maximum square into plus of 1. Yes sir. So now we have a quadratic equation available here. Slip at which torque is maximum square plus, sir, this will become 4 times of minus, you can write it. Sir, this will become minus of 4 times of slip at which torque is maximum plus 1 is equals to 0. Can I write in this way? So just by solving this quadratic equation, we are able to understand the slip at which torque is maximum. When you are going to solve this, you will get two different values. Okay, so solve this quadratic equation, you will get two roots. So slip at which torque is maximum is, please write in the comment section. Please write in the comment section and be ready with your calculators. So maximum torque will become, sir, this will be 3.73, and sir, we are getting one more value, 0.2617. Okay, as per the option, you know, you have to choose this one. Okay, because in the option, the more than one slip is not given. But please observe here. These are the two values of the slip at which you are getting torque to be maximum. So sir, can you please explain why we neglect the value higher than 1 and why we have to choose this 0.2617 or 79? I'm sorry, this will be 79. This will be 79. Okay. This will be 79. Okay. So now please observe here. Sir, when we talk about torque slip characteristic curve will be in this way in case of neglecting stator impedances or gravitational losses. Sir, this will be the torque slip characteristic curve for a rotor resistance R2 dash. This will be your maximum torque. You can say your maximum torque. At which torque is maximum can be represented here. Okay. Now please see. In case if I am increasing the rotor resistance, then what? In case if you are going to increase the rotor resistance, then slip in a high slip, torque in a high slip zone increases, torque in a low slip zone decreases, and sir, we may get in this way. Yes sir. So this will be your slip at which torque is maximum 2 at rotor resistance R2 dash 2. Okay. Yes sir. However, the maximum torque will remain same. If we are going to increase the rotor resistance further, then you can say sir, we may get this type of torque slip characteristic curve. Please observe, we never increase the rotor resistance more than this. Why? Because sir, if we are going to do so, then we are reducing the starting torque. Up to this part, your machine is going to spin in this direction. It means the field is rotating in a clockwise direction. If the field is rotating in a clockwise, let us suppose if the field is rotating in a clockwise direction and you are getting the torque to be maximum in an anti-clockwise direction, then there is no use of that torque. Is it okay? So we never want the slip at which torque is maximum in a high slip zone. We always want the slip to be maximum in low slip zone. We never want this slip to be maximum in high slip zone, in braking zone. We never want the slip to be maximum in braking zone. This is what we called a braking zone. Why I am saying this to be braking zone? Because the field is rotating in a clockwise direction and the rotor here is rotating in the opposite direction. So this is what we call a braking zone. Is it okay? So if the field is rotating in a clockwise direction, the rotor is rotating in a clockwise direction forward, moving mode, and if the field is rotating in the opposite direction, you can say that is braking zone. Is it okay? Maybe your rotor is rotating at a different speed. Okay. Yes, sir. Maybe rotor is rotating at a speed lower than. Rotor is rotating at a speed higher than. Rotor is rotating at a speed higher than. Synchronous speed is also called as a regenerative braking, but that is a generating. That is different from braking. The slip higher than 1 is said to be braking zone. Why? Please observe here. I am writing here. Slip higher than 1 is called as a braking zone. Still there is a problem? पता नहीं आज क्या गड़बड़ हो गया. The slip higher than 1, slip at which torque is maximum Sir, slip higher than 1 means greater than 1 is braking zone. Please see why. Because slip higher than 1 is a braking zone because sir, slip is basically defined as ns minus nr upon ns. So if the field and rotor are rotating in the same direction, then slip is always going to be lower than 1, or it may going to be negative when rotor speed is higher than the synchronous speed. But in case if ns and nr is in the opposite direction to the rotating field, then you are going to get, okay, slip higher than 1. Okay, so here you always going to get slip lower than 1, called as a motoring zone, and here you will get slip to be greater than 1, called as a braking zone. Because field wants to rotate always rotor in its direction. Always the flux cutting onto the rotor is in such a way that the rotor poles created will oppose the cause, and therefore rotor must rotate in such a direction that opposes the relative motion between field and winding. So if the rotor is rotating in the direction of rotating magnetic field, it is going to lower the flux cutting and lower the induced EMF. However, if you observe this one, then relative speed between rotor field, the relative speed between stator field and rotor winding is increasing. So that is representing a braking zone. Is it okay? With a rise in speed, the torque is increasing. Now please observe, we never want the slip to be maximum in a braking zone. So we always select the value of slip at which torque is maximum as lower than 1. Okay. Now please see one more question. Now please see one more question. A three phase a three phase 208 volt, I am hoping you are able to see me. Okay, a three phase 208 volt induction motor having a synchronous speed of 1200 rpm. Okay, runs at 1140 rpm. When connected to 215 volt supply. Please see, when connected to 215 volt supply and driving constant torque load. Driving constant torque load. The language is very important. Please see. Constant torque load. Calculate the speed. Calculate the speed with which. Calculate the speed if supply voltage is 200 volts. Calculate the speed if supply voltage is 200 volt, or you can say is decreases to 200 volts. I am writing is decreases to 200 volts. If supply voltage is decreases to 200 volts. Badhiya. Now please see. Sir, induction motors are highly sensitive towards the voltage. So with a change in voltage, definitely with a change in voltage, speed is going to be as we have observed in the torque expression, not only in the low slip, but in low slip zone, high slip zone, or in a braking zone also. You can say low slip zone, high slip zone, maximum torque, all are depending upon the applied voltage and its frequency. So if I am going to apply voltage of 215 volts, then induction motor speed must be affected. Okay, sir. Whether induction motor will survive, whether induction motor will remain protected if you are using 215 volt on 208 volt induction motor? Yes, I am considering it. However, we try not to apply more than rated voltage onto the induction motor, but the rated voltage are mentioned onto the nameplate by keeping the safety factor. Safety factor means there is a possibility that you can increase a 10% voltage and insulation is not going to be damaged out. Is it okay? Now please see. Sir, I am going with the solution. Please see. Sir, please see. Sir, torque in operating zone. Torque in operating zone. So I am not doing this, it will be happen automatically. So torque in high slip zone is, please see beta, taking the red one. Torque in high slip zone will become, torque in operating zone. Operating zone is always called as a low slip zone. So low slip zone torque is defined as torque tau is equals to 3 by omega Sm into V square by R2 dash into S. So you have to remember this. Always remember that torque in operating zone, when I am saying operating zone or a stable zone, it is a low slip zone. So torque in a low slip zone is equals to 3 by omega Sm into V square by R2 dash into S, because in a low slip zone X2 dash square is much lower than R2 dash by S square. Okay. Now you can say, sir, once the machine is designed, if we go with the same frequency and if we are not changing the rotor resistance, then you can say, sir, torque is proportional to, please see here, omega Sm depends upon the frequency and number of poles. I am not changing, it is not given in the question. So applied voltage per phase, R2 dash is the rotor resistance, it is not going to change, rotor resistance is not changing. So you can write it, sir, this will become V square into S. Okay, please see here. Now constant torque load means what? Constant torque load means at every different speed the torque demanded by the load will remain same. So sir, torque demanded by the load will remain same. Please see here. Constant torque load means, please observe here, if we have a machine here, if we have a three-phase induction machine, then its torque slip characteristic curve can be defined in this way. Yes sir. This torque slip characteristic curve is the motor torque slip characteristic curve. This torque slip characteristic curve is the motor torque speed characteristic curve. Okay, please see. Sir, this is your electromagnetic torque speed characteristic curve. Induction motor is always designed to operate in a low value of slip. Now please see, if the load onto the motor is of constant torque in nature, if the load onto the motor is of constant torque in nature, अभी भी हो रहा है बेटा? Please let me know if the problem of voice still persists. अभी भी अगर voice की problem है तो मुझे बताइएगा जरा. I am hoping now everything is okay. See, we have this to be the electromagnetic torque. In case if the rotational losses are neglected, why I am neglecting rotational losses? Because it is not given here. The rotational losses are not given. No data is given in such a way we can calculate the rotational losses. So I am neglecting the rotational losses. On neglecting the rotational losses, you can say, sir, electromagnetic torque itself acts as a shaft torque. And the point where electromagnetic torque and load torque are equal is said to be the operating point. So the machine will be operating at this particular point. You can say, sir, OA. Okay, sir, why you are saying this? Please see. Because if we have an induction motor, please see beta. If we have an induction motor, then sir, any motor is designed to rotate the load. So if the three-phase supply is given to this and this is going to rotate some load, then it is going to rotate some load, then electromagnetic torque is torque provided by the motor, that is because of the north and south attraction of the rotor and stator. This is your electromagnetic torque, and in the same direction machine will rotate at a speed say nr, and load always try to be in rest, so you apply torque in the opposite direction. Motor is not going to provide a constant torque load. Motor is not going to provide a constant torque. Basically, load is of that nature that it requires a torque demand to be same at any speed. Okay, sir. So at a point when load torque and electromagnetic torque are equal, then only machine will operate in a steady state condition. Otherwise, either it will accelerate or it will decelerate. Yes, sir. So now please observe here. You can say, sir, when I am saying constant torque load, it means under all operating points, the torque is going to be same. Yes, sir. We have a torque expression as torque is proportional to V square into S. Okay, sir. Please observe here. We have an expression torque is equals to V square, and torque is proportional to V square into S. So if voltage is decreasing, then for the same slip, torque is decreasing. Yes, sir. So let us suppose I am representing this to be the voltage V1. Okay. So this is your torque slip characteristic curve at voltage V1. I am going to change it to voltage V2. So if I am going to change it to voltage V2, which is lower than V1, then you can say, sir, torque in a low slip zone will decreases. Torque in high slip zone will decreases. Please see. Torque in low slip zone will decreases. Okay, sir, torque in high slip zone will decreases because that is also proportional to the voltage square, and maximum torque is also decreasing. So by changing the voltage, not only the torque in high slip zone or a low slip zone will be affected, but torque is going to be affected in every zone, because sir, already we have observed that the maximum torque in low slip zone or torque in high slip zone, all are proportional to applied voltage square. Okay sir, and the slip at which maximum torque is not the function of voltage, so with the change in voltage, slip at which torque is maximum is not going to be changed. Is it okay? Yes sir. So now please observe, at the same time when you are going to change the supply voltage, the machine is designed for 208 volts, okay, and you are applying 215 volts, so the machine is running at 1140 rpm while driving a constant torque load. So it means, sir, if we have a voltage more than V1, so V2, I am taking this to be V2, which is less than V1, and a voltage more than V1 can be represented here. Please see, I am representing here voltage V3, which is more than V1. So sir, if the machine is running at 215 volt, this is your 215 volt phase line to line, then it is running at a operating point, say OB, okay. If I am going to decrease the voltage to a rated of 208 volt, then the machine will rotate with the same load at a speed of OA. Okay sir, and if you are going to change the applied voltage to a new value which is less than the rated as 200 volts, then again sir, for the same load torque you found, the machine speed is reduces to OC. Is it okay? So sir, for a constant torque load, whenever motor operates, the motor torque will be equals to load torque. Is it okay? So when I am saying load torque is constant, so you can say the value of motor torque under operating condition is again equals to load torque only. And sir, for a constant torque load, you can say, sir, electromagnetic torque is equals to load torque under steady state condition. So for constant torque load, you can say, sir, electromagnetic torque is found to be constant. The magnitude of electromagnetic torque under steady state condition is again going to be equals to load torque. So for a constant load torque, you will always going to get the same electromagnetic torque under steady state condition. So sir, you can say V square into S is going to be constant. So if V square into S is constant, then you can say, sir, V square into S is constant. So you can say, sir, please see here, when 215 volt is applied, the machine is running at 1140 rpm, okay, and synchronous speed is 1200 rpm. So if 200 volt is applied, then we can find the value of slip by the simple relation for a constant torque as S square into V square into S to be constant, okay. So if I am saying this to be constant, it means V2 square, V2 is the new value, into S2 square, V2 square into S2 is equals to V1 square into S1. Yes sir, if I am writing in this way, you can say, sir, V2 is 200 volts square into S2 is we have to calculate this slip, and V1 is 215 volt square. Sir, why you are writing the line to line? Because we are finding the ratio, so it is not going to be affected. Now please see, again S1 is the present operating slip at 215 volt. When 215 volt is applied, the machine is running at a speed of 1140. So you can find the slip at 1140 as 1200 synchronous speed minus 1140 upon 1200 ns minus nr upon ns. Okay, so you can find the slip S2 also. Yes sir, so we have slip S2 as 215 square upon 200 volt square into the value you can calculate. Is it okay? So let me do the calculation for you. Hoping you are able to understand this. अभी भी प्रॉब्लम आ रही है? सुनील साहू बेटा अभी भी प्रॉब्लम आ रही है क्या? अगर अभी भी प्रॉब्लम आ रही है तो मुझे बताओ फिर। Now see, this will become 1200 sir, minus 1140 divided by 1200. So 0.05, and you can calculate it, multiply 215 by 200 square. So sir, this will become 0.0577. So what is the speed sir? NR will be equals to NS 1 minus S. NR will be equals to NS 1 minus S. So just put the values. NS is 1200 because frequency is not changing, so synchronous speed of the revolving field is not going to change. 1 minus 0.0577. So you can just calculate in this way. 1 minus answer into 1200. So your value, the speed will be 1130.6626. Okay. So with the change in, yet I haven't tell you anything about the speed control, but you are doing the numericals on the speed control just from the torque speed characteristic curve. I am hoping you are able to understand this. Okay. Now please see, sir. By changing the voltage, we can control. By changing the voltage, we can control the speed of the induction motor. And now we can easily observe here. By changing the voltage at the same slip, torque changes. If there is an unbalanced in electromagnetic torque and load torque, then definitely machine either accelerate or deaccelerate depending upon whether electromagnetic torque is more or load torque is more. Is it okay? And the acceleration or deacceleration will take place till the machine again attains steady state condition where electromagnetic torque is equals to load torque. So you know how to control the speed by changing the terminal voltage, or also you know what happened if the terminal voltage changes, then what happens to the speed of a motor. Okay, up to this everything is okay? Kanishk beta, why you just everything is okay? Kanishk आपने क्यों ये हटा दिया बेटा कमेंट अपना? Good. Kanishka, okay. One more question, please see. I am interested to discuss one more question. Up to this point everything is okay? यार comment section क्यों नहीं दिख रहा? Feeling little bit difficulty with the comment section. Okay. Please see one more question. A three-phase four-pole, a three-phase four-pole slip ring induction motor has rating of 110 kilowatt, 1760 rpm, 60 hertz. Three external resistance 3 external resistances of 2 ohm are connected in star. Are connected in star on rotor slip ring. बहुत ध्यान से सुनना, ये बहुत जबरदस्त है। आपको मैं पूरा इसमें जो है वोल्टेज और स्पीड दोनों की बात करने जा रहा हूं, ठीक है? ठीक है, ओके। सो under these condition, under above condition, the motor develops torque of 300 Newton meter at a speed of 1200 rpm. At a speed of 1200 rpm. Calculate बहुत जबरदस्त क्वेश्चन है, प्लीज गो विद दिस क्वेश्चन. Calculate first part, the speed, calculate speed at torque of 400 Newton meter. Calculate speed at torque of 400 Newton meter. Then again, calculate the value of external resistance required on rotor side. External resistance required on rotor side to external resistance required on rotor side so that motor develops 10 kilowatt at 600 rpm. ठीक है? Now please see. A 3-phase 4-pole slip ring induction motor has a rating of 110 kilowatt, 1760 rpm, 60 hertz. 3 external resistances of 2 ohm are connected in star on a rotor slip ring. Under the above condition, motor develops a torque of 300 Newton meter at a speed of 1200 rpm. Calculate the speed for the torque of 400 Newton meter and the value of external resistance required onto the rotor side so that motor develops 10 kilowatt at 600 rpm. Okay, sir. Please see. I am going to elaborate this question again. Please see. Suppose you have a slip ring induction motor. So please observe, you will get the basic idea of the slip ring induction motor also. So we have a slip ring induction motor available here. please see, where this is your stator, okay, and this is your rotor. So in case of a slip ring induction motor, a rotor is wounded for a specific number of phases and a specific number of poles. Okay, sir. And slip rings are facilitating the connection, electrical connection between, slip rings are facilitating the electrical connection between, हाँ जी, stationary winding and rotating winding. So this is rotating in nature, rotor is rotating in nature, it is connected in this fashion. A, B, C of the rotors are available with the electrical connection onto the slip rings. Slip rings are moving and the brushes are stationary. Okay, sir. And let me show you in this way, so it will be clearly observed to you like a star. So this will be your external resistance which can be inserted by changing the position of this okay. Yes, sir. So let us suppose we have these to be the contact points. Okay. Let us suppose up to this contact point, this will be of 2 ohm. Okay, sir. So up to the contact point, this will be of 2 ohm. Up to the contact point, this will be of 2 ohm. Okay, sir. And the slip rings are connected in this fashion. Say slip rings are connected in this fashion. Sir, say slip rings are connected in this fashion. Okay. Okay. Now please observe, we can change this contact, okay, by just Please verify if the voice is now okay. Please verify. Now the voice is okay or not? Voice is okay? Please verify if the. Now please see. NS is equals to 1800 RPM and rotor speed is given to you while motor is producing a torque of 300 Newton meter. What is the when motor develops torque of 300 Newton meter, okay, then what is the value of slip? Let this slip to be S1, so this will be equals to NS minus NR upon NS. अभी तक हमने एक चीज सीखी है, क्या? रेटिंग पढ़ना. So if 110 kilowatt, then this suggests that maximum, this suggests that the full load output power of this motor is 110 kilowatt. This 1760 is not a synchronous speed, it is a full load speed. So when onto the motor you are going to apply full load, then motor will rotate at a speed of 1760 rpm. And 60 hertz is the frequency for which this motor is designed. Now, this motor is providing a 300 Newton meter of torque when a 2 ohm external resistances are connected in star on rotor side. You have to calculate the speed when motor is providing a torque of 400 Newton meter. Okay. Now please see, sir, when motor delivers a torque of 300 Newton meter, then under that condition, let us suppose slip S is equals to S1 and it can be represented as 1800 minus 1200 upon 1800. Is it okay? So you can easily calculate the value. Please write in the comment section. Okay, sir. Now please see, we have this to be equals to 1800 minus 1200 divided by 1800. So what is the value? 0.3333. Up to this I am hoping everything is okay. Yes, sir. Please see. So this motor is operating at a slip of 0.333. Now, if the now please observe motor is providing a torque slip characteristic curve in this way. Please observe, once you are able to understand this curve, you can solve all types of question. Now the speed control is not required to study. You are able to know each and every speed control just by observing this torque slip characteristic curve. So this is very important. Please try to understand this. Sir, we have this to be the torque speed characteristic curve and the motor is providing 300 Newton meter of torque. The motor is providing 300 Newton meter of torque at a speed or at a slip of 0.3333. Is it okay? Always the motor is in a low slip zone. Always the motor is designed to operate in a low slip zone. Especially our slip ring induction motor always rotate in a low slip zone, because in a slip ring induction motor we always try to increase the rotor resistance and try to get the maximum slip at the maximum torque at the time of start. Is it okay? Yes, sir. Now please see. When the torque is increased to 400 Newton meter. Now when the torque is increased to 400 Newton meter, while all other things will remain same. So sir, under that condition, your slip is going to increase and speed is going to decrease. Now please observe here. You can say, sir, for a torque of 400 Newton meter, for torque of 400 Newton meter, it is not given that whether the voltage is going to change or not, rotor resistance is going to change or not. So we have to take all of them same, okay, as it is. Now please observe. You can say, sir, for a torque of 400 Newton meter, since torque is equals to, since torque in operating zone is 3 by omega sm into v square by r2 dash into s. Yes sir, this is the torque in a operating zone, that is low slip zone. So torque in a low slip zone is this represent that torque is proportional to, frequency is not going to change, rotor resistance is not going to change, voltage is not going to change, so torque is proportional to slip only. Yes sir, so you can say sir, new torque by old torque is equals to new slip by old slip. You can easily calculate the new value of the slip, that will become 400 by 300 into old slip 0.3333. Is it okay? Yes sir. So you have to multiply this 0.3333 just by 4. So this will be equals to 0.4444. Is it okay? Now please observe, the slip will become 0.4444. So slip increases, so what happens to speed? NR will be equals to NS 1 minus S sir. So you can just put the values now. This will become NS is 1800, 1 minus 0.4444. So the value of slip will be equals to, 1800 1 minus 0.4444. So this will be equals to 1000.08 rpm. So nearly equals to 1000 rpm. Is it okay? Please let me know if you are able to understand this. Please let me know if you are able to understand this. Everything is okay? Everything is okay? Now please see. Sir, in the next part, we want to get the desired power at desired speed. Okay, so what value of external resistance is required in order to get 10 kilowatt at 600 rpm? It means desired power from the motor at desired speed, just by changing the rotor resistance. Okay sir, so I can change this. By changing this, tappings are going to change and the resistance is going to change. With a change in resistance, I wanted to get the desired output power at desired speed. If it is possible, it means this machine is under our control. Is it okay? Okay. So we know about the language which this machine is able to understand in terms of the supply voltage, in terms of the frequency, in terms of the you can say rotor resistance. Is it okay? So only we have to command it by that language. Now please see here. You can say, sir, for 10 kilowatt at 600 rpm, for 10 kilowatt at 600 rpm, you can say, sir, we can find the torque required. Let this torque to be equals to 3. In order to get 10 kilowatt at 600 rpm, the power will be PD by omega R. Okay, the torque will be PD by omega R. Yes sir. So we have PD as 10 kilowatt. We wanted the developed power to be equals to 10 kilowatt. As the rotational losses are not given, so you may neglect them. Okay sir, omega R will become 2 pi into NR by 60, so this will become 600 by 60. Okay, so we can calculate this torque, sir. Please observe. So 10 to so this will be equals to 159.154 Newton meter. So we want the torque to be equals to this much, 159 at 600 rpm. Okay sir. Please observe here. We have the torque speed characteristic curve. This is the torque speed characteristic curve with the rotor resistance external root including external rotor resistance. We have this to be the torque speed characteristic curve. In case if I am neglecting the internal resistance of the rotor, I am just considering that this 2 ohm as a resistance onto the rotor side on per phase basis. So you can say R2 dash to be equals to 2. This will be the torque speed characteristic curve. Now you wanted, sir, to get the torque of 159 Newton meter. You are interested to get the torque of 159 Newton meter at a slip of what is the value of slip required, sir? 1800 minus 600. 600 is the desired speed which is needed for 159.4 Newton meter torque. Please observe, we want to get 159.15 Newton meter torque, 159.15 Newton meter torque at a speed of 600 rpm, and that you can represent here as 1800 minus 600 divided by 1800. Is it okay? So what is the value of slip beta? If you calculate, it will become 1800 minus 600 divided by 1800. So this will be equals to 0.67. So sir, the slip needed will be 0.67. This is your S3, S2, S1. Is it okay? Yes, sir. Now please observe. For that, you can change the resistance in such a way that new rotor resistance will have a torque slip characteristic curve passing in this way. So you know about the previous operating points. Either you can go by the operating point 1 or you can go by the operating point 2. If you know about any one operating point, then you can find the parameters required in order to operate the machine on any desired operating point. Is it okay? Just by the simple relation of the torque speed in a operating zone. This is a low slip zone. Always the motor will operate in a low slip zone. Until unless it is not given that motor is operating in, intentionally it is given that motor is operating in a high slip zone. You have to take it in a low slip zone. Now please observe, you can say, sir, we have the slip to be equals to 0.67 and sir, torque in a low slip zone is proportional to, please observe, torque in a low slip zone, or you can say torque in a operating zone. Torque in a operating zone is 3 by omega Sm into, please observe, V square by R2 dash into S. Yes, sir. Now we are not changing the voltage, we are not changing the frequency or pole. So you can say, sir, torque is proportional to S by R2 dash. Is it okay? Yes, sir. So by this you can say, sir, new torque by old torque. Old operating torque, either you can take condition 2 or condition 1, is equals to S2 by S1. S3, it is better to write S3. S3 is the third condition. Okay, so I am writing S3 by S1 into, sir, R2 dash is inversely proportional to this, so you can write it as R2 dash 3 by R2 dash 1. Okay, now please see, you can easily calculate this value. Torque required will be 159.154 upon old torque is 300, the new slip is 0.667, and this will be 0.33333. So you can write in this way, sir, R2 dash new required by old R2 dash is 2 ohm per phase. So only one unknown parameter, that is R2 dash required. So the new required value will be equals to, please calculate this, R2 dash 3. Okay, so it will be equals to 159.154. I am doing the calculation in front of you. It makes you more comfortable. You can do the calculation along with me. Sir, this will be equals to into 2. Okay, and into 0.3333 divided by 0.67. So this will be equals to new torque is 159.154 by 300, okay, into 0.3333 is the old one. So this will be equals to 0.530. Is it okay? So resistance needed to be lowered down. Don't focus on negative vibes. Good. Please observe here. Now we have the rotor resistance. The new rotor resistance required will be equals to, you can say, sir, it will be equals to this way. Is it okay? R2 dash, I have represented this one wrong. Please make it correct. चलिए, मुझे भी confusion हो गया था. R2 dash 1 by R2 dash 3. Okay, inversely relationship. So you can find it here, sir. 2 by R2 dash 3 is, you need to calculate. Okay, please calculate this one. Sir, this will be equals to, बढ़ना चाहिए ना, 159.154 by 300 into 0.3333 divided by 0.667. Okay, 2 divided by answer. So this will be equals to nearly 7.57. Oh, is it okay? Please find it. If the flux is reduced by 75% of the original value, are beta. Are you able to understand this one? Please see. Yes, sir. So you, just by changing the this tapping, you can get the desired output at desired speed from the slip ring induction motor. So the greatest advantage of the slip ring induction motor is that without changing the maximum torque provided by the motor, we can change the speed. However, in case of a voltage control method, which we have just studied before this question, see this one. In case of a voltage control method, we have observed here that with the change in voltage, the maximum torque is also changing. So definitely the torque handling capacity of the motor is reducing. So if you are going to change the voltage, then the motor is going to operate near to the maximum torque. It means more current will start flowing through the induction motor. So when motor draws more current, it will get heated, and for the duty cycle it will be designed, machine will get damaged. Is it okay? So we not prefer to go with a voltage control method. We always prefer to go with a either resistance control method, or best is to go with the V by F control method. Resistance control method will also disadvantageous, because with the resistance control method, if you are going to reduce the speed, you are going to do more copper loss on this external resistance. So the efficiency is the main concern in case of a rotor resistance control. Hoping you are able to understand this. If the flux is reduced by, अच्छा चलो Navneet, if the flux is reduced by 75% of the original value, it means phi 2. But in solution of this question, ये क्या लिखे हो बेटा? I am not able to understand. ये कौन सा question है? I haven't given this. ठीक है. Hoping you are able to understand this concept. Now please see. I am running one series named synchronous numerical series. Please observe and look on this picture. Then again I am returning back to you, and then we move forward. Please see. So, hope you have enjoyed a lot. So, by rest of the portion I start by tomorrow, that is speed control of a 3-phase induction motor, in which we are going to get the detailed analysis of voltage control, rotor resistance control and V by F control. We are also going to discuss some numericals of gate. Okay, so when I am saying we are going to discuss, it means you have to participate on the comment section. Positive participation is needed. Okay, now please see. You can follow me for getting that synchronous numerical series on Unacademy app. You can follow me on Unacademy as unacademy.com/machine.varun. Okay, and you will get all the notes on this Telegram channel. The name is Kreatryx Gate EE. Okay, so you can download the PDF from this. Now see, this is our team, and we are also running one batch named Umeed batch. Umeed batch is for those students who are still not in a fear condition. Okay, so fear condition, why I am saying, because Umeed is just the hope batch is going to give you a hope for the upcoming GATE exam, that is 2021. So you can join me at 9 PM on that batch. And all of our team members will have their subjects running on that. Please see, we are providing a complete package for GATE and ESE. So be energized and be ready for upcoming batches. Thank you, hoping you have enjoyed a lot. So like this session, subscribe this channel in order to get more videos, more technical videos. Thank you.